Let's do a couple more examples. Now I'm going to use a shortcut here, and I'm not going to make my table myself, and I don't expect you to either. We're going to use either the graphing calculator app on your Chromebook. If you have trouble finding that, email me. I can talk you through it. I've showed you in a previous video how to find that, but it's in the apps on your Chromebook. You could also go to Desmos Graphing Calculator, and it will help you as well make a table. So on this one, I know for sure, since this is just an X, I want to start with the number 0. And I'm going to try a couple numbers bigger than 0 and a couple numbers smaller than 0. But now I'm going to go smart, and I'm just going to plug that thing right into my graphing calculator. Let's scoot this over so you can see. So if you have a graphing calculator, or if you're using the app, you're going to push the y equals button, and then you're going to type in the equation. And notice this time, the only thing that's in the exponent spot is the x. So I'm going to have to arrow over and put plus 5. So you can probably imagine then, if you add or subtract a number to the end of an equation, what this is going to do to the equation. Let's take a look. So it took the 2 to the x graph, and let me just go ahead and graph that for you. Let's graph 2 to the x. So this is 2 to the x plus 5, and this is 2 to the x. So notice it's the same graph, but this point has been shifted up 5 units. So if I look at the table for this one, and let me get rid of the 2 to the x. So if I look at the table for this, so second table, next to 0, I'm going to have the number 6. Next to 1, I'm going to have 7. Next to 2, I'll have 9. And next to negative 1, I have 5.5. And next to negative 2, I have 5.125. And then I want you to take a look at the graph. See how next to negative 2, I have 5.25, and then 5.125, and then 5.00, and then 5.00. Look what happens. This output value is getting smaller and smaller until eventually it's so small they end up just saying that it's 5. Well, it doesn't really touch 5, but they can't keep making this decimal small enough so that it can be an output on the graphing calculator. So I know this time, since it's getting closer and closer and closer to 5, that my asymptote is actually at y equals 5. So this thing is getting closer and closer and closer to 5. It looks something like that. And the graph looks like this. So it does not change my domain. My domain is still negative infinity to infinity. However, the range, the smallest y value this time is 5, and the biggest y value is infinity. The asymptote is at y equals 5. And let's think about the end behavior. This end, x, is going to approach negative infinity as y approaches 5. This end, x, is going to approach infinity as y approaches infinity. Okay, let's do the next one. This time I have a multiplier of 3. So it's going to look just like the 2 to the x one, but instead it's going to be stretched vertically. So if I think about what y to the 2x looks like, I'm going to go back on my note sheet. So it's going to take each one of these values and have a 3 multiplier. So this point's going to be here now. This point's going to be way up here. So it's going to take the ends and stretch it. So let's just stick that into our graphing calculator and look at the table. If I can get this on here at the same time. So y equals, I'm going to clear out what's already there, and I'm going to type in 3 times 2 to the x and hit graph. So you can see how this one is rising. It just goes faster. So it's going to look something like this. And we can copy the table that's on our graph. So the domain, again, is negative infinity to infinity. The range goes from 0 to infinity. The asymptote is right here at y equals 0. The ends, this end, x approaches negative infinity as y approaches 0. See how it's getting closer and closer to 0? This end, x approaches infinity as y approaches infinity. So this one, just putting the 3 here, actually stretched our graph.